Okay. Good morning, my dear students. Nice to meet you all today. Okay. For today class, uh, okay, I'm going to discuss this one. Last class, I just started shape function for plane elements, two-dimensional elements, isn't it? Last class, we have seen this. Just started some introduction I gave. Two-dimensional element, we are going to see shape function for plane elements, right? In that, I told you what is meant by serendipity element family, Lagrangian family, and all. I told you. Okay, I said I will start triangular elements. Okay, this today class. That's what triangular elements. We are going to see a two-dimensional plane element. First, we are going to see triangular element. Okay, so I have a triangular element like this, right? The corner nodes 1, 2, 3. Okay, first we are going to discuss three-noded triangle only. However, I have shown the intermediate node also. If you want to do nonlinear analysis, intermediate node also can be chosen like this 4, 5, 6. Okay, this figure we will refer for three-noded triangle as well as six-noded triangle if required. Right. So how to go for a local coordinate system in this triangle? Okay, we have to do something, and we have to do something and go for a local coordinate system, right? That is natural coordinate system. Natural coordinate system. All right. Shape functions for these elements can be expressed either in xy coordinates. It means what? In Cartesian coordinates, or in natural coordinates L1, L2, and L3. Right? So shape functions for these elements can be expressed either in Cartesian coordinates, that is xy coordinates, or in natural coordinates. How do we choose the natural coordinates? L1, L2, L3 system. Okay. I told you for plane element L1, L1, L2 system, for element L1 system, L system, L1, L2 system. Here L1, L2, L3 system. Okay, what it is? How do we achieve such a system? How do we formulate such a how do we formulate such natural coordinates for this triangle? It's formulating. We are doing something and formulating a natural coordinate system. For that, what I am going to do, I am going for a system called area coordinate system. Area coordinates. See here, area coordinates. The natural coordinates is chosen as area coordinate system here. How? You consider any point within the element, this triangular element, say P, whose natural coordinates are, say, L1, L2, L3. Okay. A point P will be defined by the following set of natural coordinates. Which set of this natural coordinates? Okay. So I have chosen a point P whose natural coordinates I am taking L1, L2, L3, right? Which is arbitrarily I have chosen. No, that's why L1, L2, L3, right? Now, this chosen point subtends some subtriangle, okay, with the vertex. If I join this chosen point with the vertex of the triangle, just to see here, if I join this chosen point with the vertex, I'm getting some subtriangles here, right? So, using this, I am getting area coordinates. How? L1 I am defining as, say, the area of this subtriangle as A1. A1 by A. A is the total area of the triangle. The full triangle, no, total area of this triangle. A area. Okay. A1 is the subtriangle here, right? How do we obtain? It is subtended by the chosen point P with the vertex. Okay. Right. And L2 equal to A2. Okay. A2 by A. L3 equal to A3 by A. How do I name this A1, A2, A3 in this? See here, this is my node 1. Opposite to node 1, I am naming area 1. This is my node 2. The subtriangle opposite to my 2, I am naming it as A2. This is node 3. Okay. The subtriangle opposite to this here, I have named it as A3, right? Only concentrate on this. Forget about other thing. We will come to that discussion later. Okay. This way I am defining the area coordinates L1, L2, L3. Okay. So the further discussion where A1, A2, A3 are the areas of the three subtriangles subtended by the point B. Okay. And the nodes are as shown in figure. Subtended by point B and the nodes. Okay. Where A1, A2, A3 are the areas of the three subtriangles subtended by the points P and the nodes as shown in figure. And the capital A is the total area of the triangle. Okay. Now, some properties. See, I'm going to discuss some property. Now, I am not going to develop any shape function. Some period introduction I am giving regarding some properties, formulations. In other words, formulations. How we formulate, okay? Formulations of certain properties of this triangular element. We are discussing it here. Thus, the A1, A2, A3 is equal to A. No doubt. If I add A1, A2, A3, I'm getting the total area of the triangle. No doubt, A. Moreover, this chosen natural coordinate, that is area coordinates for triangle, is there? No. L1, L2, L3. If I add them, L1 plus L3 plus L2 plus L3 is equal to unity. Okay, 1. Right? The natural coordinates of node 1, 2, and 3 are as follows. For node 1, what is the natural coordinate? Okay, I have to get natural coordinate for node 1. How do I get? Just to imagine, you are moving this point P, okay, to node 1. This is some arbitrarily chosen point on the triangle whose natural coordinates are L1, L2, L3. If I choose this point to some known position, one is known position, just I am moving it and putting it here. Okay, now if I move this one to 1, what will happen? A2, A3 will vanish. No, area will not be there. If I move this point P to 1, A2, A3 will not be there. Only A1 will become A, isn't it? So A1 by A will be A by A, 1. Okay, so my L1 value will be 1. Okay, because L1 is defined as A1 by A. A1 is A by A, 1. That's why L1 is 1. A2, A3 becomes 0. Okay, if I move point P to 1, isn't it? This area will vanish. That is why L2, L3s are 0 value. So 1, 0, 0 is the coordinates, area coordinates or natural coordinates of 1, node 1. Next, we come to node 2. Move this point P to node 2. What will happen? This area A1, A2 vanishes. Only A2 become A, isn't it? Therefore, L2 is equal to A2 by A by A, 1. Remaining A1, A3 vanish, I told you, no. That's why L1, L3 becomes 0. So 0, 1, 1 is the coordinates. Okay, this way we are formulating. That's why formulation. We are formulating the natural coordinates, area coordinate. For that, we choose area. In terms of area of the triangle, we do something and formulate this coordinates. Okay, local coordinates, that natural coordinates we are choosing. Right? For node 3, similarly, move this point P to 3. A1, A2 vanish, A3 becomes A. So L3 is 1, L1, L2 0. That's why 0, 0, 1. Okay. Likewise, we got the coordinates of node 1, 2, 3. Right? That's what I have written here. For node 1, 1, 0, 0. Node 2, 0, 1, 0. Node 3, 0, 0, 1. Okay. Right. Here, because we are discussing some properties of this triangle, some formulations, I want to discuss further. Okay. Suppose it happened to be a 6-node triangle. Intermediate node also I am considering. Okay. 6-node triangle. How do I name? See here. Here 1 is, no, here I am starting 4. Because 1, 2 is here. So here I am starting node 4. Here node 5, node 6. Okay. Middle node 6. Right. So what is the coordinates of this node? How do we get coordinates for this node? Just we move this point P to this node, 4th node. What will happen? The triangle will be subdivided into equal, 2 halves. Okay, equally subdivided, this one. If I move P here, so A1 becomes A by 2, A2 becomes A by 2, A3 vanish, right? That is why what is this one? L1 will be half, L2 will be half, L3 is 0. Okay, so half into half, half, 0. In other words, 0.5, 0.5, 0. Okay, that's what I have written here, half, 0. For node 5, that's a similar manner. Move this node point P to node 5. Okay, A1 vanish, A2 becomes A by 2, A3 becomes A by 2. Substitute its value here. You will be getting, for node 5 coordinates, 0, half, half. Similarly, for node 6, half, 0, half. Okay, you will be getting. This way, you can obtain the node L1, L2, L3 system. Okay, and local coordinates, that is natural coordinates for the given triangular, for an triangular element. Okay, that's what. These are certain formulation and we are discussing, properties we are discussing. Okay, and the coordinates of the nodes at mid sides are Just how I told you, no? Yes. And then the area of the triangle can be expressed as a function of xy coordinates. Now, if you want to compute the area, okay, area can be computed again using these natural coordinates. But in the when you work with the finite element software, you will be feeding this coordinates and all of the geometrical properties and all by Cartesian coordinate system. Okay, so how do we calculate the area of the triangle can be expressed as functions of xy coordinates, means from Cartesian coordinates value the area can be computed. It can be shown also. Okay, A equal to half into determinant 1 x1 y1, 1 x2 y2, 1 x3 y3, where x1 x2 x3 and all coordinates of each node. See here the Cartesian coordinates x1 comma y1 of node 1, node 2 x2 y2, node 3 x3 y3. They are the Cartesian coordinates. Once you know this, the area of the triangle can be obtained. This and all in matrix method of structure, in the matrices you have studied. How do you get the area of a triangle by in matrix form? A equal to half into this way you have to write. Okay, this and all already well established. How do we get the area of the A1, this area, the subtriangle area A1? For that, what to do? Subtriangle, what will happen? Okay, subtriangle no A1. Subtriangle A1 na x2 y2 is there, x3 y3 is there. Instead of x1 y1, you have x comma y, because the Cartesian coordinates of chosen point P say x comma y. Okay, here x3 y3, here x2 y2. So instead of x1 y1, you have to put xy. That's all. Okay, see here a1 is equal to half into 1 xy, instead of x1 y1 xy. Okay, so 1 x2 y2, 1 x3 y3 as it is. Similarly, a2 equal to half into xy, that point P coordinates is xy, no? A2, you can see here, see A2 is this one. So A2, what is this? This is a subtriangle. So the coordinates are x1 y1, x3 y3 and x comma y. P, point P, no? X comma y. Okay, so if you, for that subtriangle, if you want to calculate the area, A2 equal to half into 1 x1 y1, 1 xy. Okay, you should not put x2 y2, instead of that xy, the point P. Okay, and 1 x3 y3, and a3 equal to half into 1 x1 y1, 1 x2 y2. Instead of x3 y3, you have to substitute 1 xy. Okay, determinant value. Okay, determinant of this all these things. This is the basic thing for properties of a triangle by matrix form. Once you know the Cartesian coordinates of the points, this way you can able to compute the area of triangle, or the whole triangle, and then the subtriangle areas can be obtained in matrix form this way. Some properties we have been discussing. Okay, because fully it's the properties of elements only this topic. Okay, so just now I told, yeah, that's what. So how do you get a relationship between the Cartesian coordinates and natural coordinates can be shown as follows. The relationship between Cartesian and natural coordinates can be shown as follows. How do you get the relationship between them? Okay. The relationship between Cartesian and natural coordinate can be shown as follows, right? See, L1 plus L2 plus L3 is equal to 1. That I already told you. See, L1 into x1 plus L2 into x2 plus L3 into x3 is equal to x. If you do it, okay, L1 plus y1 plus L2 plus y2 plus L3 into y3 is equal to y. These are the properties. Okay, we know because the natural coordinate L1 into x1 plus L2 into x2 plus L3 plus x3 will give you x value. Okay, so likewise, this is written as 1xy is equal to this. You must know the, okay, you must, this is the way you have to do it. 1xy, in matrix form, we are writing this equation in the matrix form. 1xy is equal to 1, 1, 1, x1, x2, x3, y1, y2, y3, L1, L2, L3. Because if you multiply, 1 is equal to multiply L1 plus L2, L3 you are getting. X is equal to x1, L1, x2, L2 plus x3, L3 you are getting. Similarly, y is equal to y1, L1 plus y2, L2 plus y3, L3 you are getting. Okay, this equation only written in the matrix form. This way we can establish a relationship between Cartesian and natural coordinates also. Okay, the system will do it if required. Now I am coming to the further discussion. Okay, only triangular only I am going to see. We are going to see in this class, right? Derivation of shape function for plane elements, right? Derivation of shape function, linear model. Okay, we are going to see three-noded triangle, linear model. First, we are going to take a three-noded triangle. For this, I am going to use the method setting up equations of lines. Please, this is the best way. That method alone can be used here. Then when compared to Lagrangian polynomial, generalized coordinate system, okay, generalized coordinates method and all cannot be used. Only this may be used, but see here, this is the convenient method, setting up equations of lines for this kind of elements. See, n1 equal to unknown parameter k into equation of the line passing through node 2 and 3. Okay, so in the triangle, if you want to get the n1 shape function for node 1, what to do? You should not consider this point. Only the remaining nodes, no. See, I have not drawn separate triangle for three-noded element. Sorry, three-noded triangular element. Here I have drawn six-noded triangular element. Time being, forget about the intermediate nodes. Time being, all of you forget about this intermediate nodes. Only concentrate 1, 2, 3, three nodes. Okay, three-noded triangle, right? For this, if you want to get shape function for node 1, forget about node 1, only 2 and 3. Okay, line passing through 2 and 3. You have to set up a line passing through 2 and 3. So what is the line pass equation of line passing through 2 and 3? At 2, L1 is 0. At 3 also L1 is 0. Okay, only the L1 value has got 0 value, both node and 2 and 3. Therefore, L1 equal to 0 is the equation of line. Okay, that's what. So that is written here. I have shown here, right? So N1 equal to K into L1. L1 equal to 0 is the equation of line. I told you, no, that L1 you have to take unknown parameter into L1. We know at node 1, N1 has got a unit value 1 is equal to K into L1 also has got unit value at node 1. Therefore, K is equal to 1. Therefore, N1 is nothing but L1. Okay, N1 is nothing but L1. L1 is the natural coordinate. Okay, that's what we got. So how it's very should be just some rough discussion. Don't think too much. Just whatever I am telling, just to have a look. Okay, this triangle, say at node 1, N1 has got unit value. It has got 0 value at other nodes. That's why it's very should be something like this, right? And then N2 equal to K into L2. Okay, in a similar manner, if you do it, because equation of lines. If you come to 2, please see here, if you come to node 2, at node 1, which one got 0 value? At node 1 and 2, which one got 0 value? L1 is not having 0 value. L2 has got 0 value at both the node. Therefore, L2 equal to 0 is the equation of line passing through node 1 and 3. Okay, L2 is equal to 0 is the equation. So you have to take this L2. Similarly, for other one, this one, for node 3, the equation of line passing through node 1 and 2 is L3 is equal to 0. See, L3 is 0. Okay, commonly. That's why L3 is equal to 0 is the equation of line. Right? So this way you have to proceed. N2 equal to K into L2, L3 equal to K into L3. So you know, as I told you, similar, 100% similar to that of this. Okay, do it. So N2 equal to L2, N3 equal to L2, N3 equal to L3. Okay. So here at 2, it has unit value. Okay. Node 2, no. Node 2, N2 has got unit value, and the other nodes value is 0. So it's very should be something like this as shown, right? As shown. Variation will be something like this as shown here. Okay. Variation of N2. Variation of N3 also as shown. N3 has got unit value at node 3 and 0 at other nodes. That's why you have to join like this. Okay, some variation. Just displacement. Okay, variation of displacement. Exactly cannot be shown. Some roughly try to understand. Don't think too much in this. Okay. So displacement at any point will be, you know. So the nodal displacements are, say, U1 at node 1, U1 V1. At node 3, U2 V2. Okay, in XY direction. At 3, U3 V3. Once your shape functions are known, N1, N2, N3 are known, you know the displacement at any point, say UV. UV can be obtained as at any point within the triangle, the element U equal to N1 plus U1 plus N2 U2 plus N3 U3. This is the fact you know. V equal to N1 V1 plus N2 V2 plus N3 V3. Okay, this way we can obtain it. Some discussion only we are doing. Now I am coming to the 6-nodal triangle, which is quadratic model. Okay, once the 6 node quadratic model, that's nonlinear. For nonlinear analysis, we use 6 node triangle. For linear analysis, we use 3 node triangle. Okay, in the plane element. Okay, 6 node triangle, which is quadratic model or nonlinear model, right? So I am considering all the 6 nodes, 1, 2, 3, okay, whose coordinates also given 1, 0, 0, 0, 0, 1, 0, okay, 0, 0, 1, and half, 0, 0, half, half, 0, half, okay. This have to be watch very carefully. Shape function of n1. We are going to obtain shape function for n1. You should not consider this node. Line passing through equation of lines. You have to set up equation of lines passing through the other nodes. Okay. For that, how we do it, right? Here it is shown here. Here n1. Here itself I drawn n1. Okay. The equation of line here is L1 equal to 1. Equation of line here is L1 is equal to 0.5 or L1 minus 0.5 is equal to 0. Why? See, you take these two nodes. At these two nodes, L1 value is half commonly. The other values are different. See, that is why the commonly L1 is half here. Okay, so if you set up equation of the line of nodes, line passing through nodes 4 and 6, okay, what to do? The L1 equal to half is the equation of the line. Okay, therefore L1 minus half is equal to 0 or L1 minus 0.5 equal to 0. This is the equation of this line. Okay, similarly here L1 0. You take a node 2, 3, 5, line passing through all these 3 nodes. Okay, see the L1 value is 0 in all these coordinates. So L1 equal to 0 is the equation of line passing through all these 3 nodes, right? So L1 equal to 0. Therefore, N1 equal to some unknown parameter into, you are writing N1, no, you should not take this node. The remaining nodes, line set up equation of lines passing through the other nodes. Okay, here 2 nodes, here 3 nodes. You have set up equation. So L1 into, this is L1, no, this is L1. L1 into L1 minus half. Okay, therefore, N1 has got unit value at node 1. That time, what is the value of L1? L1 also has got unit value at node 1. Substitute. Okay, so you will be getting, which implies k equal to 2. If you substitute N1 equal to L1 into 2L1 minus 1, you are getting. So the shape function N1 is obtained as L1 into 2L1 minus 1. Okay, so later you do it. You have to practice more. See, I am teaching just by referring these notes and all easily. Earlier I used to, in physical mode of teaching, I used to do everything on the board without referring the notes. Okay, now easily I am referring the notes, just I am discussing with you. But as a student, you have to practice a lot, right? You have to study, understand, and then you have to take a note and you have to write in your own. This way you have to work hard, you have to practice, right? So because there's a cut, it is covered, bottom portion is covered in the next page, right? N1 obtained. Shape function of N2, right? N2 equal to, how do you get here? Its variation also is shown. Please see here, N1. N1 has got unit value at node 1 and it has got 0 value at other nodes, no? So its variation will be something like this. Some variation, we are showing some variation. Okay, shape function, so deformation or something. Okay, its variation is shown. You refer any standard textbook about C.S. Krishnamurti and all, you can see this kind of representation, graphical representation of variation of shape function N1 for 3-nodal, 6-nodal triangle. Okay, let us check. Okay, next one, later you check it, any textbook. Okay, next shape function of N2. N2 equal to equation of line, I am writing. This is node 2, no? So here L2 equal to half, here L2 equal to 0, here L2 equal to 1. Okay, so this is the equation of lines. Therefore, you have to take this L2 into L2 minus half. Okay, similarly, that's why I written similarly. Therefore, N2 equal to, instead of L1, L2 into, here 2 L1 is there, no? 2 L2 minus 1. Okay, similarly, N3 is equal to, instead of L1, L3 into 2 L3 minus 1. Okay, so up to this easy. all the N1, N2, N3 you obtained for 3 nodes. There are 6 more, another 3 more nodes are there, okay? Because it's a 6-node triangle. 1, 2, 3 we obtained a shape function. 4, 5, 6 we have to obtain shape function. Let us see. How do we get it? Deriving N4, okay? For N4, what I have done, see here my nodes, N4 equal to K into, which is the 4th node? This is the 4th node, isn't it? If I join this node and this node, and this node, line passes through this node. So I should not consider equation of this lines. I should not consider the equation of this line. I have to consider only equation of this line and that line. This is L2 equal to 0. This is L1 equal to 0. So take this L1 and L2. Okay, L1 and L2. K into L1 and L2. Okay, N4 must be 1 at node 4 when here L2, L1 value must be half, isn't it? So not only L1 value alone, L1 and L2 value must be half here. We know the coordinates. Half L1, L2 values are half. Substitute. Therefore, K equal to found to be K by 4. Okay. Sorry, K is found to be 4. K is found to be, the unknown parameter K is found to be 4. Therefore, N4 equal to 4 into L1, L2. Okay. Deriving N5. Similarly, we can write N5 equal to 4 into L2, L3. Similarly, N6 equal to 4 into L1, L3. How L2, L3? L1, L2, and then L2, L3, then L3, L1, right? 4 into L3, L1, right? In that order. In the order, no. L1, L2, L3 is there. L1, L2, L2, L3, and then L3, L1, right? You can return L1 as L3, 4 into. Okay, I have some sinus problem. It's okay. Right? I have to take some medicine. Right, results all. See here, this triangle is there, no? See here, at node 4, it has a unit value. So the shape function is like this. It has got 0 value. It tapered. Actually, like this triangle, it is tapered to 0 here. Right? To other nodes, it's tapered. It has got unit value here. See here, for the 5th node also, it's got unit value. Variation will be like this, it's shown. 6th node also unit value, its variation is shown like this. That's all. The discussion is over. So next element is a rectangular element. That we will see it in the next class. Okay. Please, since I am referring notes, I can able to finish fastly this one. But in the physical model class, it will consume a lot of time because I have to do it, draw on the board and explain. Okay. But here everything well already written, ready-madely available. Okay. So just I am seeing it and explaining how do we do it. So we have to work hard. I advise you to practice. Okay, that's all about some formulation of element properties for triangular element. To a 2-node or 3-node triangular element and 6-node triangular element, how to develop shape function in terms of the natural coordinate system, L1, L2, L3 system. I told you. Okay, how do you get this L1, L2, L3 and all? From area coordinates. They are area coordinates, right? So please see here, all this kind of computation that program does, your finite element program will be doing. Okay, the analysis. So we have discussed, that's all. Next class, I will start rectangular element. For this, we go for another system, natural coordinate system, R and S system. Okay, that is a natural coordinate system we are going to follow. I will do it in the next class. I will finish today. That's all about today class. Okay, I think always I will record your names. Okay, only some 1 or 2 absentees are there, no problem. So I have recorded your names. Right, out of 24, 22 of you are attending, maybe 21 of you are attending out of 24. It's okay. Right, I recorded your names, right, just for record purpose. Good. So with this, I will stop today's discussion. Bye to all of you. Right. First, let me to stop writing. Then we will discuss anything to be discussed. We will discuss.